And you can bring the other without potato now.
All right, thank you everyone for being here today. I'm going to talk to you about aluminum, how it's processed, and its benefits to society. First, I'd like to talk to you about, tell you a story of a U.S. Army captain. Him and his unit were in Afghanistan. They were out on patrol in Humvees. As they were driving down the road, their Humvee hit a IED. IED exploded, destroying the Humvee. All individuals were saved because of the aluminum armor that was installed on the Humvee. He told us the story when he first started in the plant and was very excited about working for a company that produces such a product that saves the lives of our service members. A little bit about myself. I worked at Arconic for 10 years as a team coach. We produce aluminum sheet, plate, and coil for different applications such as automotive, aerospace, and industrial applications. We'll talk to you today about the processes as far as how it's mined, the casting of aluminum, the rolling processes, scalping processes, heat treating processes, through our finishing processes, and then the benefits of those. As far as the mining processes go, aluminum is mined in countries such as Brazil, Australia, and India. It's an ore. It's called bauxite. Bauxite is dug up. It is sent to a smelter. At that smelter, it is introduced to sodium hydroxide, and that creates alumina. Alumina is then refined into aluminum. At this stage, aluminum is pure aluminum. It is then cast into small ingots, about 1,500 pounds each. These ingots are then shipped off to different facilities throughout the country or the world. Once they get to the plants, it is then sent to an ingot plant. At this ingot plant, what they do is they take scrap from of certain alloys that we want to produce, and then put it into a melter. At the melter, we melt it down to a liquid form and then transfer it. The ingots themselves can be introduced into it to make it more pure type of an alloy. We can also add commercial metals at that point to make it into specific alloys. We may introduce copper to it, magnesium, manganese, just depending on what the alloy is. At this time, it'll be about 180,000 pounds worth of metal, and then we cast that into ingots. Now, an ingot of the size that we produce is roughly, we'll just say 24 inches thick, 84 inches wide by 300 inches long. Very large, approximately 40,000 pounds, maybe a little bit heavier than 40,000 pounds is one ingot. Once the ingot is cast, it's pulled from a pit and set and air cooled. Once it's cooled, it goes to a scalper. At this point, the machines, the ingot is laid flat, and giant knives rotate around and then take off the top and bottom surface to remove any impurities. And it does that because once we do the rolling process, we don't want those impurities in the metal itself, so we remove them there. After it's been scalped, it's then taken to a preheat furnace and put in a furnace and heated up anywhere from 700 degrees to 1,000 degrees, depending on the practice, depending on the product and what it's going to end up being. It's done so because we need the metal to be soft and easier to roll. It's rolled in our rolling department, and we have several mills within the rolling department. 3 of them are reversing mills, and 1 is a continuous mill, and then we have 2 cold mills farther down the line. The hot rolling mills, they roll the ingots back and forth until it goes from that 24 inches thick down to, could be 12 inches thick, could be 1.5 inches thick. Once it reaches that 1.5 inches thick, we'll say, it goes on to the plate mill. So now the plate mill will take it, and then they will heat treat it, saw it, mill it, and then cut it into wings for aircraft. Everybody's seen a wing. so on an airplane. So that's what we produce. We produce those wings for Boeing, for Airbus, just the structures of it. All right. We also produce the skins for the aircraft. That's done at a later step. So as the plate mill's done with it, they will ship the metal out after they've heat treated it, and then put it in a tank for ultrasonics. Ultrasonics is a step where they immerse it in water and run a scanner over it, looking for any inclusions or anything like that to make sure that there's no voids in the metal, which could cause fatigue or anything like that. Back over to the rolling area, we would continue to roll the aluminum through the other reversing mills and through our continuous mill into a coil form. Coil is just a big coil of aluminum, and it would be roughly max size of 40,000 pounds of coil. It is then sent down to the cold mills, where it's either heat treated in another furnace or it's ran through the cold mills once it gets to room temperature. It is then rolled down into a lighter gauge of metal, which would be 30 thousandths thickness, and then it could be sent on to Ford Motor Company. So Ford would make it into hoods, door panels, fenders, lots of different applications there as far as automotive. We also make skin sheet for aircraft. That is sent over to another area where they make it into panels and then send it out, and then therefore they're formed and sent on and make the skin sheet for aircraft. A good example of that would be American Airlines. They have the nice shiny skins. That is skin sheet. That is polished skin that Arconic makes. Once it gets off the cold mills, it would go into our finishing PCs, which would maybe split the metal down into smaller sizes or multiple coils, just for different customer orders. Automotive treatment lines, which would go to Ford. They do some more heat treating processes just to help make sure that the metal is strong enough for those applications. Once it gets through that, it would go to IPS, and then they would ship it out. That is the process for producing aluminum. So we covered rolling, scalpers, casting, finishing PCs, plate mill. Some of the benefits of aluminum: it's lightweight. It's been around for 125 years, and 75% of what's been produced is still being used today. So the other 25% hasn't been recycled. So it's recyclable, it's strong, has a good carbon footprint, and the carbon footprint, basically it's lightweight, so we're saving on fuel costs, energy reduction based on it's used on buildings, it reflects the heat from outside, so it saves on cooling costs. With that said, thank you for your time.